Good evening. You're on the Smoking Section with Keldin Sergheyev and me, Stephen Helfer.
Hi, Stephen.
Hi, Keldin. Thanks for coming in this terrible weather. It's really
Thanks
good
for having
you're
me.
here. It's really good you're here. You look very, like you did a lot with your beard. Your beard seems very...
Wet?
Well, no. It seems very trimmed and so forth.
Oh, that's remarkable.
You look very stately almost. Let me ask you, now, we were going to talk about, we have this ongoing discussion about science, and I'm always somewhat critical of science and particularly the way it's practiced, and I was just, I thought maybe we were going to go over p-values. You were going to explain that to us.
Yeah, I would love to.
Oh, great. And you came upon some kind of 30-page article, which is very critical of how they are used to mislead these days in certain journals.
Yeah, I thought you would want to see that as some ammunition, so I dutifully sent it along to you.
Yeah, but it's too much for me to read. Listen, I'm just so busy, but this book, I just came upon this book by a guy named Agus. David B. Agus.
Don't know it.
He is a medical doctor, and he's kind of a bit of a theorist. But it's interesting because I think he's very, very biased in many ways. And let's just go into it a little bit, if you wouldn't mind. Because, for example, he has this... let's just see, I wrote down a little bit of what he said. I thought it'd be interesting because, if I can find it, of course, in my, he says, he was talking about the whole vaccine controversy. And I'm not a partisan in the vaccine controversy, but I tend to be very skeptical of a lot of scientific and medical orthodoxy. And of course, the medical orthodoxy is that it has been overwhelmingly proven that vaccines are safe. So I just thought I would go over a little of his argumentation here and ask you for commentary.
Okay. I have to say, I'm disappointed. I send you an article and you don't read it, and then you show up with something I can't even prepare for.
Oh, I'm sorry. Forgive me. I need all the handicaps I can get. So, but
I'll do my best.
Well,
we're not opponents in this anyway. We're working together towards the truth from different starting points. So.
Yeah. So, for the example, he writes in I kind of paraphrase this, but he writes in 1998, a British doctor announced that he had found a relationship between the MMR vaccine and autism.
Okay.
And the MMR vaccine is mumps, measles, and rubella.
Is this a Wakefield study?
Yes, this is the notorious Wakefield study.
Yeah, Wakefield has been discredited.
Yes, right. I mean,
probably 24 times over, but
well, of course, I don't know.
Let's run with it. Okay. Assuming Wakefield.
I don't know much about the original study, but there's been a lot written on this stuff, and so I don't think it's fair to. I don't know about this particular study, but according to the doctor, Wakefield, according to Wakefield, who had studied a scant 12 children, 3 vaccines taken together could alter the immune system and ultimately damage the brain. So far, everything he has said has been very factual, but then he goes on to say, this Dr. Agus, his findings landed in the British medical journal, The Lancet, and took the world by storm. Mm-hmm. Now, he uses the term landed. The British medical journal, the Lancet is probably the most prestigious medical journal in the world, along with the New England Journal of Medicine.
Some kind of chance happening when really you should earn your place in the journal, right?
Well, I mean, there is that presumption.
Yeah, okay.
And here he is, Dr.
I think we're on the
Agus.
same page so far.
Now how does, if this study used a scant 12 children,
How did it even get published?
well, of course, I don't know if 12 children is a lot or a little, or it depends on the study. I mean, you might be able to do a study with very few participants.
So the number of participants is N.
Oh, really? Okay.
Is the letter N, lowercase n, in statistics.
Right.
And so we talk about the size of N. Is it large N? Is it small N? You can make
But
up.
why would there be a large N? I mean, a large pool of participants.
Yeah, large sample size. It's the sample size. That's
Right,
what
and then, of course, you have the sample size, and then it gets involved into what we call the laws of probability. Right, presumably the
Sure.
larger the sample size, the more
Well, let me
reliable
interrupt.
go ahead, please.
Yeah, let me interrupt you. You can make up for a small sample size by showing a large effect in that small sample. So a very large effect in a small sample can result in equal statistical significance to a small effect in a large population.
Can you give an example of that? I mean, for example, let me see if this is an example. If I give strychnine, a certain dosage of strychnine to 12 participants in the study, and all 12
of them
die.
Right. Yeah, you don't need 12,000 people to show that, because the effect is so large, a small sample size is acceptable. And above all, the most important thing in selecting a sample is that it's simply randomly selected.
Right.
Simple random sample.
Right, of course, which is impossible to do perfectly. We can never do that perfectly, because one of the problems is, for example,
You can show very clearly when it is done terribly, but yes.
I mean, for example, all of the studies that are done at Massachusetts General Hospital are that we see advertised on the subway. Rich, educated white people don't join those studies for the most part.
If that's true, then yeah.
Well, I mean, I
that's a
assume
bad
so, because
selection.
they're not, like, Donald Trump is not going to go down to MGH because they promised him $250 to, donate something, right?
Yeah, that's correct.
And I don't think, to make it fair, I don't think John Kerry is going to do that either, right?
It's so fair.
So that's a problem.
You're fair and balanced.
That's a problem, though. That's a problem, though, in scientific studies. But
Yes. That is the problem.
but I mean, this is a case like. See, I'm trying to look at this guy's bias, Dr. Agus. If he believed in it, if he believed in something, then he would say, "Oh, well, this study was published in the Lancet and it's peer reviewed." But here, he doesn't believe this particular study. So the fact that it's published in the Lancet doesn't mean anything to him. That it's peer reviewed, it would appear. It's a bias, in my opinion.
I don't think you get to make arguments about the intentions of the scientists so much. You have to analyze their methodology. So if he criticizes this study and he makes a valid criticism, it's irrelevant what his personal view on the study is.
No, that's true. But what I'm saying is that, for example, anti-smoking activists always say, well, this was published in a peer-reviewed journal. It would not have gotten into the journal unless its methodology was good. And I mean, I see this in science all the time, particularly
Would not
medical
have gotten into the journal. It's less likely that it would have gotten into the
But
journal.
again, the laws of probability, right?
Everything's probabilistic.
Yeah, I don't know if I'll buy that, but it could be, I suppose. I mean, I don't know about that. I mean,
Even strychnine has an LD50. It's probably a very small
Yeah,
dose
right,
that only
right,
results
right.
in 50% of the population
The
dying.
dose-
But
the
there's
dose
an
makes the
LD50.
poison. The dose makes the poison,
Right.
which is the fundamental law of toxicology.
Is it? I'll take that.
Formulated-
Sounds about right.
Formulated by Paracelsus,
Okay.
the father of toxicology.
Okay. Thank
But
you.
your field is physics more than...
Sure.
Okay, so then another thing he says, and here's something that maybe you can opine on well, because
Yeah.
you know quantum physics.
I can almost guarantee that quantum physics has no bearing on this, but
Because then he says,
we're talking about huge macroscopic systems.
He
Quantum
talks about the
almost-
fallacy of post hoc ergo propter hoc,
Okay.
which means because A happened, because B followed A, B was caused by A.
Okay.
And he says when one thing happens after
More
another.
commonly known as correlation does not mean causation.
Well, except here we're talking about something where time is very important, but
Okay.
it's so like for example, you smoke and then you
Get lung cancer.
are X, Y, or Z. We can assume simply because X, Y, or Z happened after you smoke. It's because you smoke and you lose your hair at a certain point. You get male pattern baldness, and if you smoke, then it must have been caused by smoking.
Oh, okay.
Right. But I mean, he says when one thing happens after another, it does not mean the first thing caused the other. Which I will, but then we get into cause. But I'll buy that. But my question to you is, how do we know that causation? Am I using the word correctly?
Yeah.
Must go before.
You stopped saying causality, so that's
Okay, good. Causation. How does that? How do we know? How can we scientifically show that for something to cause something else, for A to cause B, A must occur before B?
I would like to completely give up the word causation.
Is that right? Wow. Okay.
Yeah.
Okay. Because we always assume that, it's like, for example, if I, let's say, get lung cancer and then 10 years later I start smoking, we really assume that smoking can't have caused the lung cancer. But why do we assume that? Because that's right. We assume that
One of these days I'm going to look up
precede.
how they define cause in the medical community, but
Right.
to me it's almost irrelevant. Just the correlation is enough for me to make a decision.
Because you believe everything is probabilistic.
Right, if you show me that there's a correlation between two things, and that correlation also extends to the absence of both of those things, meaning that if you take away the presumed correlate and then the resulting correlate also disappears, then that's enough for me to believe that it should be a risk factor, or it's something that I'm going to make a decision based on, right? So in the case of smoking and lung cancer, I don't really need to know that smoking causes lung cancer. The correlation between them is so high that it's enough for me to make a decision. If I'm going to bet on smoking causing lung cancer or bet on smoking not causing lung cancer, I'm going to bet on smoking causing lung cancer.
Right, I suppose so.
I'm going to bet on...
Guess what?
What?
We have a phone call.
Oh, that's exciting. Let's hear it.
You're on the smoking section. I think. Oh, wow. Here we go. Pick up. Hello.
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 Welcome to the smoking section.
Thank you. Do you have a cigarette with you?
I certainly do.
I'd like to do a very quick joke with you.
Well, I mean, the thing is, the cigarette I have with me is a roll your own cigarette, and I don't have time
All
to.
right, that'll work perfectly.
That will work perfectly. You mean I have to roll a cigarette?
Oh, you don't have one already rolled?
No, I don't. That's the problem.
I'll try it another time.
Yeah, thank you very much for calling. We're on every Wednesday at 7 o'clock, and next week I will be sure to come with a rolled cigarette.
For a joke. Yeah.
For a joke, I'm always up for a joke.
Life is the joke. Life is the ultimate joke.
Well, here's what. Okay, the last thing I'll just bring, and then we'll get into the this is something that's a little bit political. Then he goes, when scientific data clearly proves that a particular vaccine can reduce the risk of contracting a certain illness with few to no side effects, we as a society should demand universal inoculation, and that the only exception should be for for medical reasons.
This is Agus talking. Dr.
Angus, yeah, Agus.
Agus.
I mean, that seems like a pretty, I mean, normally in our
Quite a
country,
bold statement.
well, right, it's certainly
Scientists.
very totalitarian. I mean, what do you do with people who refuse to be inoculated? Do you kill them, or, you put them in prison, or you tie them down and inoculate them? Usually in our country, we do make exceptions for these kinds of things for bona fide religious objections.
Right.
Like, for example, there are people with bona fide religious objections who don't have to buy Obamacare or mass health.
Right. Well, this is me opining now.
Please.
I think when you're dealing with modern day risk, right, we've eliminated all of the huge risks for the most part.
The low-hanging fruit.
The low-hanging fruit, yep, you're using my terminology now. Obviously, some of the low-hanging fruit, we didn't pick them completely, like apparently we're still having problems with lead, but they're
In Flint, Michigan.
right, which is a problem that should be solved, yesterday, but the remaining fruit are not low-hanging fruit. The remaining risks to be eliminated to create a safer world are not huge risks.
I see.
That's
Right.
in general. There are still large risks out there to eliminate, but most of the risks we talk about are small. And so when you try to go eliminating them, it's people, I think, lose sight of the size of the risk.
And they become control freaks, maybe.
I don't know that they necessarily become control freaks because their actions would not be misplaced if the risk were higher.
Oh, okay. All right. Yes.
you
Right.
know-
Well, I mean, yeah, but that's the same as being a control freak. Like, for example,
I don't want to use the word control freak.
Okay.
That has so much baggage. I can't use that.
but I mean, for example, I'm not a vaccine partisan.
Right.
But I just try to look at, for example, about a year ago, approximately this time last year, a lot of the press was talking about, at the behest of people in the medical profession, about the rise of certain diseases in certain areas
Right.
of California.
Yeah, avoiding vaccines is a greater risk than most of the other risks that we freak out about. So I understand it completely.
Should we pick up a phone?
Sure.
You're on the smoking section.
Hey, Steve, it's David.
David is on the smoking section with us. David, what's up?
David.
Good. What did you think about Kurt Schilling saying that chewing tobacco caused his cancer?
Right. Well, I think probably the most, well, he wasn't really chewing tobacco. I don't know what he uses, but the most knowledgeable person about that is a man named Brad Rodew. And he says it's very unlikely, and he's not even sure. He says the risk of getting oral cancer from chewing tobacco is minimal to none. And he is a pathologist, an oral pathologist who teaches at some university and is a big proponent of what is called smokeless tobacco because he thinks it's extremely safer than combusted tobacco. Did you see our article on Facebook? David?
Not yet, but there's a time delay. Is there a time delay on this call?
Yeah, there must be.
What is time, though? That's the problem. But
In other words, I'm hearing. Forget it.
well, how is it?
Thanks for answering that question.
Okay, thank you for calling up. I think our Facebook page, Cambridge Citizens for Smokers' Rights, opined or presented some scientific information from a man named Brad Rodew, and who is an oral pathologist, disputing, because Kurt Schilling right now is making public service announcements about the dangers of smoking tobacco, of using chewing tobacco, because he says he has oral cancer.
Okay.
You haven't seen those, I guess.
No, but one guy is just n equals 1. It's a really small sample size.
Right, but there is this perception that has been promoted, and that's one of the reasons they banned it.
Yeah, I'm sure there's a study out there, but one guy saying, hey, I used smokeless tobacco and I got oral cancer is not the same thing as a scientific study. It's just n equals 1 that has no statistical power.
Right.
Which I'm
Well,
sure
it
you're
has-
happy to hear.
No,
but
thank you. Well, I mean, I wouldn't say it has no statistical
Give credit
power.
where
I mean,
credit is
anecdotal, you know, the plural of anecdote is data.
If all the anecdotes are measurable, yes.
But I mean, what do you think about this demanding? I mean, this sounds like a real kind of medical totalitarianism, demanding that everybody. I mean, I'm not saying people shouldn't get vaccinated or they should get vaccinated. I'm simply saying,
Let me interrupt you. Let's propose this notion of marginal risk, which is the amount of risk that's added with each additional person who does not get vaccinated. Okay?
Yes.
If you only have 5 people in all of the United States that don't get vaccinated, the marginal risk is quite low.
Right.
But if we're already at, 150 million people, let's say, that aren't vaccinated, then each additional person is adding quite a bit more risk. There's
Yeah.
something, I believe it's called the umbrella effect, or maybe the shield.
The herd.
Yes.
They use the term herd immunity.
Herd immunity, right. So the idea is that if you have 100 people vaccinated and there's only one person in the whole group, the 101st person is not vaccinated, the likelihood they're going to come in contact with the disease to which they are susceptible is very low.
Yes.
Because everyone else is already vaccinated, so they can't possibly convey the disease to them. Right?
Right.
So the marginal risk in that scenario is quite low. It's basically acceptable for society to let them not be vaccinated. We can afford the additional morality of giving them the freedom of choice.
Right.
In a situation where few people are getting vaccinated, it's harder to make that claim that we can't afford to purchase that morality in a way.
I see.
We can't afford the choice in that situation because the choice is too expensive.
We're out of time. I'm sorry we didn't get to the P factor. Thanks for watching. Thanks
You're
for being
talking
on.
about it the whole time.